Okay, here is section 9.2, the homework for pre-calculus. You are given angles at which you are asked to find the sine, cosine, tangent, cotangent, cosecant, secant of, and find the exact value. That's without not using a decimal answer. So what you have to do, because we do not know the answers without using a calculator on these, we're going to take a look at the triangles, the special triangles that we already know. So let's look at the triangles. Let's draw them, because I don't want to keep redrawing them. So if we have a 30, 60, 90 degree triangle, 30 degrees, this side is 1, this is 2, and this is root 3. And if we had a 45, this is 1, 1, and root 2. Now you also need to understand that 30 degrees is pi over 6. 60 is pi over 3, and 45, of course, is pi over 4. This will help us when it comes time to taking these angles, and if they're in radian mode, we can easily find the ratio. Okay, so now the first question is asking you for the sine of pi over 12. So what you need to do is you need to look at pi over 3. Look at pi over 4. Look at pi over 6. And let's convert these to 12s. Okay, all of them have to be converted to 12s. So if you multiply this by 4, you have to multiply this by 4. So this would be 4 pi over 12. Multiply this by 3, this would be 3 pi over 12, and by 2. So this would be 2 pi over 12. So using these measurements now in replace of the ones that we know, which they're the same, how can you use the addition and the subtraction identity to take two of these and add or subtract them to get pi over 12? Well, you can use pi over 3, which is this one. So if we take pi over 3, these two, which is 4 pi over 12, and we subtract pi over 4, which is this one. So in other words, the sine of 4 pi over 12 minus 3 pi over 12, well, that's going to give us pi over 12. And really, you're doing the sine of pi over 3 minus pi over 4. Okay? So now, you have to know what the subtraction identity says. The subtraction identity says you take the sine of the first angle. So you're going to do the sine of pi over 3. You're going to multiply by the cosine of the second angle. And you use the same sign. So it's a subtraction. And then it would be the cosine of the first angle. And then times the sine of the second angle. So now, looking at these, you want to find what is the sine of pi over 3. So you're going to go to pi over 3, sine of pi over 3, that would be root 3 over 2. The ratio is root 3 over 2. Times the cosine of pi over 4 would be 1 over root 2, or you could say root 2 over 2. And then minus What's the cosine of pi over 3? That would be 1/2. And how did I get that? You're going to go right here to this angle. Cosine of pi over 3, and it's adjacent over hypotenuse. And then what's the sine of pi over 4? Again, that would be root 2 over 2. So now, you are asked to simplify this. How would you simplify it? Well, how do you multiply these? What is root 3 times root 2? That would be root 6 over 4. Minus 1 times root 2 would be root 2 over 4. And now we're going to put these together. This would be root 6 minus root 2 all over 4. That is an exact answer. Okay, number 3. Number 3, we still want to use, we can use these same angles to get pi over 12. So we can just go ahead and go tan of 3 pi, we'll say 4 pi over 12 first, minus 3 pi over 12. Because that gives us pi over 12. Okay, so 4 pi over 12 is what? It is pi over 3 minus pi over 4. In other words, that's equal to that, this is equal to that. Now we need to use our identity. What does the tangent identity say? It says you take the tangent of the first angle, and then it's the same sign, tangent of pi over 4, all over 1. You're going to change the sign. So if this is a minus, this will be a plus down here, and then it's going to be the product of these two. So tangent of pi over 3, tangent of pi over 4. Okay, so now where are we going to get these ratios? These ratios are found by using these two triangles. So pi over 3, what would be the tangent? Would be root 3 over 1. So this is root 3. So now all we're doing is replacing these values, these tangent of pi over 3, you're going to look at your 60-degree angle, and that's going to be this is equal to root 3 minus, now you're going to look at a 45-degree angle. 45-degree angle, what's the side opposite over adjacent? That's 1. And then 1 plus, it's the product of these two. So what's root 3 times 1? It's root 3. Now, this answer is the answer that you are getting, but there's a problem. It's not rationalized. So you're going to have to do one more thing. You're going to have to rationalize this answer. So on the side here, what's root 3 minus 1? How did we learn in Algebra 2 to rationalize this? You have to multiply by the conjugate. The conjugate is it's the different sign of this bottom. So it's 1 minus root 3 over the same 1 minus root 3. Okay? So your job now is to multiply. You're going to FOIL. Root 3 times 1 is root 3. Root 3 times root 3, that would be minus 3. And then minus 1, I'm just FOILing. And then plus root 3. Now the bottom, before we can simplify that in a second, 1 times 1 is 1. Now the next two will cancel, and that's the beauty of doing the conjugate, is because you don't have to do, you're doing your FOIL, but these two you don't have to do because they're going to cancel out, because it's the difference of two perfect squares. So now what's root 3 times root 3 would be 3, and it's always a minus sign here. So now let's simplify this. These two are like terms. We've got 2 root 3 minus 4 over negative 2. Okay? Now, I could break this up. You've got 2 root 3 over negative 2 minus 4 over negative 2. So these are going to cancel out, so you have negative root 3, and these two cancel, plus 2. That's your answer. Some people don't like to leave this negative hanging in front, so you'll probably see this answer is 2 minus the square root of 3. But either one of these is fine for that answer. Okay, the next one is a whole lot of fun, and the reason is because this is a cotangent one. So really what you're going to do is you're going to flip this. You're really doing 1 over the tangent of 5 pi over 12. Okay, so for this one, you're actually doing this whole identity in the denominator, and then at the end you're going to want to flip it. So keep in mind, it's 1 over. So it's 1 over the tangent. Now what we have to do is think about what two of those numbers is going to give us a sum of 5 pi over 12. Okay, so if you look at, I would do 3 pi over 12 and 2 pi over 12. Okay, so 3 pi over 12 plus 2 pi over 12. Why did I pick those? Well, because this is 3 and 2 gives you 5, and this is, we know this is 1/4, and this is 1/6. So pi over 6. We know these angle measures. So really what you're doing is you're going to replace this as pi over 4 plus pi over 6. So we're going to do the identity, but it's all the actions really happening in the denominator here. So here we go. Here it is. 1 over. So how do you break up this identity? It'd be the tangent of the first angle plus the tangent of the second angle all over 1 minus the tangent of pi over 4 times tangent of pi over 6. So now this is where we replace everything. Okay, so it's 1 over, and then in the denominator we have the tangent of pi over 4 is 1. So where am I getting these numbers from? Pi over 4. Pi over 4 is a 45-degree angle. So tangent is opposite over adjacent. So that's where the 1 comes from. So this is equal to 1 plus tangent of pi over 6. So here's pi over 6. That'd be 1 over root 3. Or you could say root 3 over 3. I'm just going to leave it as 1 over root 3. Now we have 1 minus, it's the product of these. 1 times 1 over root 3. So, remember, this is your numerator right here. That's your numerator, and this is your denominator. All this is in the denominator. So what your job is to get all this together, and then you're going to flip and multiply. So let's ignore this right now. Let's just work on this piece right here for a second. So we want to get this together. What is another name? Let's rewrite this as root 3 over 3. So you have 1 plus root 3 over 3. So we can make this 3 over 3. So this is equal to 3 plus root 3 over 3. So that's what this is. Now this is going to be 1 minus, this is going to be root 3 over 3. So we can make this 3 over 3, and this would be 3 minus root 3 over 3. okay? Now, this is a fraction that if you're going to flip and multiply, so 3 plus root 3 over 3, you're going to flip this and multiply it. These are going to cancel, so in the denominator you have 3 plus root 3 over 3 minus root 3. Now this is in the denominator, that's in the denominator, so you have a 1 here. So you have right now 1 over, and then you have 3 plus root 3 over 3 minus root 3. So now what you're going to do is flip and multiply, and if you flip and multiply, this is going to come up here, and this is going to be in the denominator now, once you flip and multiply. So if you were to take this and flip it, you'd have 1 over 1 times 3 minus root 3 over 3 plus root 3. So what you have is this. So now what you're going to do is multiply by the conjugate. What is the conjugate? Because we don't want to have a radical in the denominator. It'd be 3 minus root 3. So 3 times 3 is 9. You have 3 minus 3 root 3 minus 3 root 3, and then plus 3. And then 3 times 3 is 9. The next two cancel out, and then minus 3. 9 and 3 is 12, and then minus 6 root 3 over 6. And it looks like 6 goes into both of these, so I'm getting 2 minus root 3 for an answer. And that is the correct answer, believe it or not. 2 minus root 3. Okay, number 7. Number 7. What two numbers are going to add up to be 7 pi over 12? So let's think about that. 7 pi over 12. That would be tangent of pi over 3 plus pi over 4. So the identity says, take the tangent of the first angle plus the tangent of the second angle over 1 minus the product of these two. So what is the tangent of pi over 3? That would be root 3. So this is equal to root 3. This is equal to 1. And then it'd be 1 minus the product of these two. So this answer needs to be rationalized. So you're going to take that and you're going to multiply by the conjugate. So what is the conjugate? Conjugate would be 1 plus root 3. So we have root 3 times 1 is root 3. Root 3 times root 3 is just 3. 1 and plus root 3. All over. 1 times 1 is 1, and then minus 3. So adding these two up, you get 2 root 3 plus 4 over negative 2. So this goes into that, and that goes into this. So this is going to cancel. You're going to have root 3 minus 2. Actually, this is going to be a negative. That's not a negative. This is 2 root 3 plus 4. So if you divide that, that's going to be negative root 3 minus 2. This is the answer. I don't know why I put a negative there. Next one, cotangent is just like that cotangent up here. except for, again, you're gonna be doing this in the denominator. So you're gonna have 1 over the tangent of 11 pi over 12. So it's 1 over the tangent of 11 pi over 12. So what two angles add up to be 11 pi over 12? Now this one's a little different. What I would do for this one, you're going to have to use 2 pi over 3 and pi over 4 to get 11 pi over 12, because 11 pi over 12 is close to pi. So you are actually, this is where you're at, right here. So you have to add more than pi over 6 and pi over 3 and pi over 4. So converting your angles as much as you can, you're going to end up with the tangent. The two angles that you're going to add up are 8 pi over 12 and 3 pi over 12, because this is one of the harder ones. 8 pi over 12 is 2/3 pi, and we know the answer to that one, plus pi over 4. That's how you get 11 pi over 12. Okay? So if you added these up, you end up, there you go. You end up getting the answer. So you may want to look at the unit circle for this one, if that'll help you, to figure out what the ratio is. So you're in quadrant 2 here for 2/3. So I could quickly draw, that will help draw you a unit circle. So if we did, this is 1/6, and this is your pi over 4. I should say pi over 6. Pi over 6, and then pi over 3, and then we have pi over 2. Here's your 5 pi over 6. We've got 1/4, this is 3/4, and 1/3, this is 2/3. Okay, so you are actually taking, for this one, you're taking this angle right here, from here to here, from here to here, 2/3, and you're adding this angle, pi over 4. That's what's going to give you pi over 12. And what we did, you have to convert this now. This was converted to 8 pi over 12, and this is converted to 3 pi over 12. Okay, so if you added these two angles, that's how you get your 11 pi over 12. Okay, so now what we do is we use our reference angle. This is a 60-degree angle right here, from here to here. That's 60. So you're going to use the ratio of a 60-degree angle, but you have to remember tangent, what the signs are. The side opposite and the side adjacent. So tangent is negative in quadrant 2. So when you're doing this ratio, it's going to end up being negative. Okay, so this is your 60-degree angle, or your pi over 3. So this is gonna be root 3. This is 1, and this is 2. But remember, this is negative 1. So when you do this one, your cotangent, you should know that you've got right here, remember that you've got 1 in the numerator. Now we have to break up our identity. Don't forget that. Let's do that right now. So we have 1 over 1 in the numerator. So now we have the tangent. Don't forget you're breaking up 2 pi over 3 plus pi over 4. So it's tangent of 2 pi over 3 plus the tangent of pi over 4 all over 1 minus the product of these two. Once you figure these out, you just multiply them. Well, the nice thing about tangent of pi over 4, it's 1. This is equal to 1, this is equal to 1. But this is the little stinker right here. This is a 60-degree angle in quadrant 2. So this is what I was talking about. You're going to use this angle right here. Tangent is opposite over adjacent, so it's root 3 over 1. Or you can just say negative root 3. So when you plug these in, this is going to be negative root 3, and so is this. So you have 1 over 1, and then this is going to be negative root 3 plus 1 over 1 minus the product of these, which when you multiply these two, you're going to get a plus. Whoops. So this ends up being plus. Sorry about that. So now understanding that you're basically flipping and multiplying, this whole thing is going to go in the numerator, and this is going to be in the denominator. And I'm going to switch these two spots. Now, we can't leave our answer like that. We have to multiply by the conjugate. So it would be 1 plus root 3, 1 plus root 3. So when you multiply, 1 times 1 is 1. 1 times root 3, you got 2 of these. And then plus 3. And then 1 times 1 is 1. The next two cancel. And 1 and 3 is 4. And 2 goes into that negative 2, and that goes into that negative root 3. So there's your answer. Okay, last one. We've got 105 degrees. Now how can we add two angles together to get 105 degrees? Now we're just using regular degrees. Well, the two, if you think of a unit circle, what two angles add up to be 105? It's 60, thinking about the unit circle, 60 and 45 add up to be 105. So this identity says the sine of the first angle times the cosine of the second angle. Opposite sine is the same sign, so it's cosine of 60 times the sine of 45. Well, the sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. Cosine of 60 is 1/2. And sine of 45 is root 2 over 2. So this would be root 6 over 2. Root 6 over 4, sorry, plus root 2 over 4, which you get root 6 plus root 2 over 4 when you simplify. Okay, this was a 2-day assignment, so the next problems were on this, I believe, on the second day. Okay, so here we go. These ones are just asking you to expand the identity and simplify it in terms of sine and cosine. So this next one, we've got the sine of pi over 2 plus x. So the identity says the sine of pi over 2 times, it would be the cosine of the second angle, same sign, so cosine of pi over 2 times the sine of x. Well, we know pi over 2 is a 90-degree angle, and the ratio here is 1, and this is just cosine x. And at pi over 2, this is 0. 0 times anything is 0. So this goes to nothing, so your answer simplifies to be cosine x. Number 15, the identity, and this is a cosine identity and it's a subtraction. So it's the cosine of the first angle times the cosine of the second angle. Opposite sign, sine of the first angle, sine of the second angle. Now, 3 pi over 2 is right here. 3 pi over 2 has the ordered pair 0, -1. The definition of cosine is x over r. Well, at this spot, x is 0. So this is going to be 0 over 1, which is 0. So this whole thing is 0. So 0 times anything, this is canceling out. Whereas over here, the sign is y over r, and the y value is -1. So this is going to be the sine of x times -1, which is just negative. You can bring that -1 in front, so it's negative sine x. Number 19. If you look at this one alternates sine, cosine, so it's a sine identity, sine, cosine, sine, cosine. So it's the sine of the first angle times the cosine of the second one. So it's a sine identity. So the first angle we're going to call, that's going to be your x. And then your second angle, which would be, we'll call it y. Okay? So we are going to subtract, so it's sine of 3 minus 5, which is -2. Okay, next one. 21. Okay, now you gotta look really carefully at this one. This one says cosine, cosine, sine, sine. We're going to call this x plus y the first angle, and we're going to call this the second angle. Call it B. See, cosine, cosine, sine, sine. So this is definitely a cosine. Whereas the first angle is going to be your x plus y, and your second angle is going to be your y value. Now with the cosine one, it switches the sign, so this will be a minus. So what ends up happening is these two cancel out, so your answer is cosine x. Number 23 ends up, you have to simplify this side, and then you're going to subtract that side. So I'm going to use another sheet of paper because I really don't have a lot of room there. How are you going to expand cosine of x plus y? So cosine of x plus y this would be the cosine of the first angle times the cosine of the second angle. Change the sign. Sine of the first angle, sine of the second angle. So all of this is just this piece right here. Then we're going to do minus. We have to break this piece up. This would be cosine of x, cosine y. Change this sign. Sine x, sine y. So now what we want to do is distribute this negative. So let's rewrite this. Cosine x, cosine y, minus sine x, sine y. And I'm just going to put this underneath. This is going to be minus the cosine x, cosine y, and then minus sine x, sine y. So this is what you have. It's just too big to fit on one line. What ends up happening, these two are the same, so these cross out. And so you end up with -2 sine x, sine y. -1 plus -1 is -2. Okay, 25 is the next one. 25. So, it says if the sine of x is 1/3, the sine of x is 1/3, and this tells us that we are between, our x value lies between 0 and pi over 2. That means we're in quadrant 1. Okay, so let's draw. You are in quadrant 1. So our x value, so this is the side opposite over the hypotenuse. So we're going to call this a 1, this a 3. So we could use the Pythagorean theorem to figure out what that other side is. How do we do that? 1 squared plus something squared is equal to 3 squared. So something squared is equal to 9 minus 1. So something squared is equal to, you take the square root of both sides, so this would be 2 root 2. Or you could just say square root of 8 if you wanted to. So then what you want to do is figure out this identity. So how do you read this identity? It's the sine of the first angle, so pi over 4 plus x. So it's the sine of the first angle times the cosine of the second angle, plus the cosine of pi over 4 times the sine of the second angle. Well, the sine of pi over 4 and cosine is 1, right? And for this one, the cosine would be 2 root 2 over 3. And this would be, the sine of this is 1/3. So your job now is to simplify this. So you've got 2 root 2 over 3 plus, 2 root 2 over 3 plus 1/3. So I end up with 2 root 2 plus 1 all over 3. I'm sorry, I have an error. I had a feeling something was wrong. Okay, back up, right here. This is my error. This is root 2 over 2. This cosine of x would be what I had before, 2 root 2 over 3, plus this is root 2 over 2, times 1/3. There. So now we're going to simplify this. This is going to be 2 times 2, which is 4 over 6, plus root 2 over 6. So the answer would be 4 plus root 2 over 6. That is correct. Okay, 27. You are between pi and 3 pi over 2, so this tells us we are in quadrant 3. So let's draw our triangle in quadrant 3. And this is x, not theta. So our cosine is defined as adjacent over hypotenuse. So this is going to be -1, and this is 5. We probably have to figure out what this is. Now, using the Pythagorean theorem, we're going to figure out that that side is root 24. And it's going to be negative. And how you get that is you're going to do each side squared and subtract and figure out what that side is. So, and you can simplify that too. You can take a 2 out. Okay? Okay, so now let's look at this definition. We've got the sine of the first angle, cosine of x, same sign. Okay? So we are talking about a 60-degree angle. So this is pi over root 3 over 2. And for this, it would be 1/2. So when we're talking about this angle, what is the cosine of this? It's actually given to you as -1/5. And then this one, we have to figure it out based on this. This would be negative root 24 over 5. So multiply across, you get negative root 3 over 10. These are some nasty answers. And then this would be plus root 24 over 10. And again, you can simplify that because here's 24 and so you have 2, you could write that as 2 root 6, like that. This is 2 root 6, and that's another version of the answer. Okay. And we have these last ones, which I'm having difficulty seeing. Okay, it says 29. It says cosine of x plus y, I believe. Cosine of x plus y. Okay, now this one tells you where x is, and it tells you where y is. It says x and y lie between 0 and pi over 2. So they're both, x and y are both in quadrant 1, but they're 2 different angles. So what you have to do, the definition of cosine would be the cosine of the first angle times the cosine of the second angle. Opposite sign. Now the x and the y value that they're talking about are, you have to draw your triangle, both triangles, I should say, and you're going to want to look at what the ratios are. So, these end up being kind of messy, but needless to say, we have to do them. So for, let's look at sine of x. X is 0.8, and I have to use separate paper because it gets, so we have sine of x, so our x, here's our x value. It says sine of x is 0.8. Well, 8 is 8/10. And if we simplify this each by 2, we get 4/5. So this is 4, this is 5, and this would be 3. 3, 4, 5. Okay. Next, our y value is in quadrant 1 also. And for this one, they just give you that y is root 0.75. So I'm just going to call this 0.75 in this one, because I can make a ratio with that. So what you have to do is use the Pythagorean theorem. Okay, we have to square these. So 0.75 plus x squared equals 1. Subtract 0.75. Looks harder. So we end up getting 0.5. So now, your identity, we're going to use this information to fill in the information here. The cosine of x, we're going to go to triangle x. The cosine of x is 3/5. Now we go to y. Cosine of y, it'd be 0.5 over 1. Or you could say 1/2 if you wanted to. Minus the sine of x would be 4/5 times the sine of y would be square root of 0.75 over 1. Now for this, you can just use your calculator, and since they gave you decimal answers, you can go ahead and get a decimal answer for this. And I believe you end up getting negative, using a calculator, negative 0.393. And now you're going to use this same information for these 3 problems right here. So all you have to do, you've already done the hard part of figuring out the x and y ratio. So now for this one, and I think it says, I'm sorry, it's hard to read. I believe it says the cosine of x minus y. We're going to say cosine of x minus y. So for this one, you're going to do the cosine of x times the cosine of y plus the sine of x, sine of y. So again, you're going to use these same numbers from this triangle. So using your x, cosine of x would be 3/5. Cosine of y would be 1/2. Sine of x, here's x, it'd be 3/5. And then the sine of y would be square root of 0.75. and then do your math. So really, the only difference between this problem and this problem was this one was a subtraction and this one was an addition. So this answer you should get for 31, you should get 0.993. In the last one, the tangent of x plus the tangent of y all over 1 minus the tangent of x times the tangent of y. Where do these numbers come from? You're going to use these two triangles again. So the tangent of x is 4/3. So this is 4/3. Tangent of y would be, and these are going to just be really awful looking fractions. So this, based on our triangle, would be root 0.75 over 0.5. Oops, I'm sorry. Yeah, this is y. All over 1 minus the product of these. So use your calculator, follow order of operations, and you should get negative 2.79 for this question. And that's the end.